What was the last point? I think this was the last point. Wave number, right?
Yes.
Okay, so in the last lecture, we have discussed what is wave function. What is wave function? Wave function is basically the function of space and time. That is equation of wave, or you can say wave function. Now, if we have a traveling wave means energy in one region will go from first region to second region. That will be called as a traveling wave. So energy which is available here in this region will be after some time available here. That is a traveling wave. For traveling wave, we have this equation, this partial differential equation. Dou 2y by dou x square is equal to 1 upon v square into dou 2y by dou t square. What is v? V is the wave speed. V is the wave speed. For this equation to be satisfied, we need y to be a linear function of position and time. So you can call it as ax plus or minus bt. If you make this a equal to 1, then this b will become b by a. And you can call it as v. You can call it as v. Right? Now the wave equation. This wave equation we discussed. For this equation to be satisfied, we need the function to be a linear combination of x position and time. Then we solve this example also. Now what is a harmonic wave train? It is a very special wave function. What is the very special wave function? It will be the function, but it will be the sine function. Which special functions will be there? A sine function means the particle is going to oscillate in y direction. So its equation of oscillation will be a sine omega t plus alpha. But this is the equation of oscillation of particle at origin. But we know when a wave travels, all the particles in the space oscillate. So we shall write a sine omega t plus alpha. And let's say our wave is propagating in positive x direction. So these people will be lagging in the phase. The oscillations will start here first, and after some time they will start here. So these people will be lagging in the phase. So you can write minus kx. Their phase will be lesser compared to the phase of these particles. So you can write minus kx. If the wave is traveling in the negative x direction, then these particles will have higher phase. So you can write plus kx. So in short, let us write plus or minus kx. So that is our simple harmonic wave. Means particles are oscillating simple harmonically. Then we have discussed parameters of the waves. The first parameter is amplitude of the wave. Amplitude of the wave is actually amplitude of oscillation of each particle in the medium. Phase constant alpha means initial phase. That is initial phase of whom? Initial phase of oscillation of whom? Initial phase of oscillation of particle at origin. Because all these particles are oscillating. Let's say this is the particle at origin. Let's say it starts its oscillations from the extreme position. Then its initial phase is going to be equal to 90 degree. So that initial phase of oscillation of particle at origin is the phase constant of the wave. Then we discussed angular frequency. Angular frequency of the wave can be defined as 2 pi upon t or 2 pi f, where t is the time after which wave repeats itself. Basically, it is time period of oscillation of any one particle of the medium. Basically, it is time period of oscillation of any one particle of the medium. Now f, the frequency of the wave. The frequency of the wave is actually number of oscillations of any particle of the medium in 1 second. Number of oscillations of any one particle of the wave, any one particle of the medium in 1 second. The number of oscillations per second is equal to frequency of the wave. Then we discussed wave number. Just like angular frequency omega, we have wave number k. What was omega? Omega was 2 pi upon t. Here we have 2 pi upon lambda. What is this t? Time after which wave repeats itself. And what is this lambda? Distance after which wave repeats itself. Means if you take a photograph of the wave, at photograph means fix the time. At time equal to 0, let's say the string looks like this. At time equal to 0, let us say that the string looks like this. Okay. Then the distance between the particles which are oscillating in phase, let's say this particle is at the positive extreme, this particle is at negative extreme, this particle is at positive extreme. So this particle has phase equal to 90 degree, this particle also has phase equal to 90 degree. So these are the particles having phase equal to 90 degree. So the distance between the particles having equal phase or same phase, that distance is the wavelength. You can check after this much distance, the wave is actually repeating itself. You can also take this distance. After this distance also, wave is repeating itself. You can actually take this distance also. After this much distance, wave is repeating itself. So you can say distance between successive crests, or distance between successive troughs, or distance between any 2 points having same phase. Distance between any 2 points having same phase. Now what is the phase of this particle? Anyone tell me, what is the phase of this particle? It is at mean, so the phase is going to be either 0 or 180. What will be the answer? Our wave is traveling in positive x direction. What will be the phase of this particle?
180.
What will be the phase of this particle?
180.
180 is a wrong answer.
0.
The phase is going to be 0. We already have discussed this many times. Our wave is traveling in rightward direction. Means wave will reach this point first. It will start its oscillation. This particle will start its oscillation earlier compared with this particle. So this particle will be lagging in the phase. So this particle is at 0 phase. So right now it is at origin. If you take the photograph after some time, then you will see the photograph looks like this. Let us remove the unnecessary part. Hmm. Now suppose this is our wave at time equal to 0. The string, photograph of the string looks like this at time equal to 0. What happens very next time? After very small time, this wave will appear like this. This wave will appear like this. What does that mean? Let us draw it properly. Let us try to draw it like this. At time equal to 0. This was the string, and let's say wave is traveling on it, means all the particles on this string are vibrating. So someone will be at mean, someone will be at extreme, again someone will be at mean, like this. Now, after some time, the photograph will look like this. You will have a feeling that the wave has traveled forward. You will have a feeling that the wave has traveled forward, but actually wave has not traveled forward. What has happened is this particle, this is the photograph at time equal to 0, and this is the photograph at time equal to dt. After some time, dt, 0 plus dt means dt. Actually what has happened, this particle has came down, this particle has came down, this particle has went up, this particle has went up. So you can check, this particle is at 90-degree phase. It is coming back to the mean position. Focus on the initial wave. And this particle is at mean, and it is actually going towards the positive extreme, means this is at mean position and going towards the positive extreme, means its phase is 0 degree. Is that clear? This particle has phase equal to 90 degree. You can check the previous wave. This is the previous wave at time equal to 0. Its particle is here. It is going down, means its phase is 90 degree. And this particle, after some time it will go up. After some time it will go up, means actually it will go towards the positive extreme. Right now it is at mean and it is going towards the positive extreme. So the particle is right now at 0 phase. So these people, the people which are ahead, will be lagging in phase. Clear?
Yes.
So this particle is right now is at negative extreme. So its phase will be, don't say 270, because people which are ahead are lagging in the phase. So 90 minus 90, 0. 0 minus 90, minus 90. Minus 90 minus 90 will be minus 180. The phase of this will be minus 180. Phase of this will be plus 180. Means, what is the meaning of plus 180? It is at mean, but now the very next time it will go towards the negative extreme. You can check what will happen if this wave moves forward. If this wave moves forward, the shape of the wave will look like this. Shape of the wave will look like this. What does that mean? This particle is right now at mean, and the very next time it is going to, it is going towards the negative extreme. This is our initial wave. This is our initial wave. After some time, you will observe that you will have a feeling that this wave has moved forward. Actually nothing has moved forward. Actually particle has moved. This particle has moved downward. This particle has moved downward. This particle has moved downward, and these particles are moving upward. Clear? So this particle is at mean and going towards negative extreme, means its phase is actually 180. This is what you need to understand. Clear? Okay. Now we know distance between successive particles which are in phase. Distance between successive particles which are in phase. सेम फेज मध्ये असणारे जे पार्टिकल्स आहेत त्यांच्यामधलं डिस्टन्स दॅट इज अ वेवलेंथ. Now the parameters, the frequency and time period related parameters are actually decided by the source, and the wavelength and the speed parameters are actually decided by the medium. Speed and wavelength are actually decided by the medium. Speed, wavelength, this k are decided by the medium, but the frequency, time period, angular frequency, these parameters are decided by the source of the wave. Now let us try to understand phase difference and path difference. The argument of the harmonic function y is equal to a sine omega t minus kx plus alpha is called as phase of the wave. Argument means whatever is written inside the sine function. Whatever has been written inside this sine function is known as the argument. Function should not be minus sign or plus cos or minus cos. Function should be plus sign. This coefficient has to be a positive number. Whatever is written inside this plus sign function is called as the phase of the wave. Whatever is written inside this plus sign function is called as the phase of the wave. So what is phase of the wave? What was written inside the plus sign function? What was written inside the sine function? Omega t minus kx plus alpha. This minus sign indicates that. This minus sign indicates that our wave is traveling towards the positive x-axis. So what is the phase of the wave? It is omega t minus kx plus alpha. Okay. The phase of the wave changes both with the position and the time. They are saying the phase of the wave changes both with position as well as with time. Yes, phase of the wave changes with the position. It also changes with the time. The change in the phase with change in the time delta t for fixed value of x is, okay, what we have to do? We have to fix the value of x. What does that mean? Fix the position. Okay, we fix the position. Then what happens to this particle? Right now it is here. It will go up. It will come down. It will go down. It will again come up. Like this means it will start oscillating. So if you fix the position, then with respect to time, the phase of this particle is going to change. What does that mean? Right now its phase is 0. Now it will become 90. Now it will become 180. Now it will become 270. And finally it will become 360. So at given position, the particle is oscillating. So the phase is changing. Change in phase is equal to how much? 2 pi. When change in time is equal to one time period, means after one oscillation. Change in phase is equal to how much? Change in phase is equal to how much? 2 pi. Initially phase was 0, 90, 180, 270 and 360. So phase changes by what? By what value? 2 pi radian. When particle oscillates for time equal to capital T. Then what is the change in phase if particle oscillates for time equal to delta T? What is the change in phase if particle oscillates for time equal to delta T? Answer is very simple. Change in phase is equal to total change in phase upon total time into your time interval. Is this formula clear to all of you? If it oscillates for only T by 4 time, if it oscillates for T by 4, means for 1/4 oscillation. After 1/4 oscillation, what will be its change in phase? Change in phase. It will change its phase by pi by 2. If it was 0, it will become pi by 2. If it was pi by 2, it will become pi. Is this clear?
Yes.
So this is the formula for change in phase in time interval equal to delta t. This is the formula for change in phase in time interval equal to delta t. What if we want to calculate change in phase of the wave with change in position, that is delta x, for the fixed value of time. Here we have to write fixed value of time. If you fix the time, what does that mean? When you fix the time, it simply means this. You take a photograph. Let's say this is a string. On this string, there is a wave. On this string, let's say there is a wave like this. You take a photograph, you will see this particle is available here. This particle is actually here. This particle is actually here. Okay. So all the particles of this string are somewhere. They are oscillating and they are somewhere. If you take the photograph, means you fix the time. When you fix the time and if you check what is the phase of this particle, the phase of this particle is actually 90. If you check what is the phase of this particle, it is 0. What is the phase of this particle? It is minus 90. What is phase of this particle? It is minus 180. I am just decreasing 90 degree. What is phase of this particle? It will be minus 270. What is phase of this particle? It will be minus 360. Okay. So what is change in phase? Can I say change in phase? You can check from 90 to minus 270. What is change in phase here? Here the phase was 90 and here the phase is minus 270. Do the subtraction. The answer will be what? 360. Let us write it as 2 pi. Means after traveling a distance equal to wavelength, lambda, the phase changes by amount equal to 2 pi. So phase changes by amount equal to 2 pi if the distance traveled is equal to wavelength. Then for any general distance, what will be the change in phase? Answer will be very simple. Change in phase is equal to total change in phase upon total distance into your distance. Is this formula clear? Change in phase of the wave changes by what value if you travel a distance equal to delta x. Means let's say you move from this point to this point. What is this distance? 1/4 of the wave or 1/4 of the wavelength. So when you travel 1/4 of the wavelength, obviously phase will change by 90 degree. You can check total change in phase upon total wavelength or upon total distance, you can say, into your distance. What is your distance? It is lambda by 4. So this lambda cancels. So 2 pi upon 4. 2 pi upon 4 will be what? Lambda by 2. Pi by 2. Check whether it is clear or not. How to calculate phase change? Is this clear?
Yes.
So once again, we know equation of simple harmonic oscillation. Y is equal to A sine omega t plus alpha. But oscillations are not only taking place at origin, they are everywhere. So let us take them into the equation. Minus kx or plus kx, depending upon whether the wave is traveling in positive x or negative x. These are all simple harmonic oscillation. Whatever is written inside this sine function is called as a phase. This phase can change with the time, it can change with the position. So change in phase is equal to total change in phase upon total time into your time. Or change in phase is equal to total change in phase upon total distance into your distance. So phase can change with the time, phase can change with the distance also. This change in distance or distance traveled is called as path difference. This is called as path difference. Delta x. Delta x means distance between this particle and this particle. Means let's say wave looks like this. Okay. So this particle is right now at mean. This particle is somewhere here. So distance between these two particles is called as path difference. Distance between these two particles is called as path difference. So corresponding to path difference delta x, we will have the phase difference delta phi. We will have the phase difference delta phi. So this delta x is also called as path difference. This is phase difference, this is time difference, this is phase difference, this is path difference. Path difference, time difference, phase difference. Okay. Let us move on to the next slide. Wave velocity and particle velocity. Let us try to understand what is wave velocity and particle velocity. Let me read this. The wave velocity or the phase velocity is the velocity of the disturbance that propagates through the medium. Yes, let's say right now the string looks like this. After some time, the string will look like this. You will feel that this crest has traveled here. This crest has traveled here. This shape was initially here. This shape was initially here. Now the same shape will appear here. Same shape will appear here. What does that mean? Wave has traveled. Now how to determine that speed? Let us try to understand. The phase of the plane progressive wave is a constant value. What does this mean? The phase of the plane progressive wave is a constant value. What is phase of the wave? Y is equal to A sine omega t minus kx plus alpha. This is the phase of the wave. What is the phase of the wave? Omega t minus kx plus alpha. Now they are saying this phase shall remain constant. Now phase shall remain constant means what? It means this. Here, right now this particle is at phase equal to 90 degree. Right now this particle is at positive extreme. Same particle, sorry, not the same particle, same phase will be available here after some time. This phase equal to 90 degree is right now available here. After some time, this particle will go to the positive extreme. Means the same phase 90 degree is available here. Is that clear? Meaning of phase shall remain constant. Initially, shape looks like this. Means this particle is at 90 degree. After some time, this shape comes here. Means this particle is at 90 degree. So to find out the velocity of the wave, you have to make the phase constant. Phase changes with the position and time. But if you want to find the velocity of the wave, then you should consider any fixed value of phase and you check. Right now the phase equal to 90 degrees available here. After some time, the same phase 90 degree will be available here. It means make the phase constant and observe that 90 degree phase is initially here. After some time it is here. Now check this distance, divide by time, you will get the speed of the wave. Is the method clear? How to calculate phase of the wave? How to calculate speed of the wave?
Yes, sir. Yes, sir.
So what you have to do is, for time being, assume any phase. You can assume phase equal to 89, 90, 91, 73, whatever you want. Okay. And make that phase equal to constant, you will get velocity of the wave. So this omega t minus or plus kx plus alpha is equal to constant. Alpha is constant. Constant and constant will become constant. Take the derivative with respect to time. So this omega into derivative of time with respect to time is 1. Then this k or minus k, you can say derivative of x with respect to time is dx by dt is equal to 0. Now take this omega on the right hand side. So minus k into dx by dt is equal to minus omega. Cancel this minus minus. Take this k on the right hand side. What do you get? Dx by dt. dx by dt is the distance traveled. Dx by dt is what? This is the distance x. So dx upon dt will be what? The speed of the wave. So what is speed of the wave? Speed of the simple harmonic wave. It is omega upon k. Any doubt in this? How to calculate speed of the wave? Take any constant phase and observe the phase. Right now, phase equal to 90 degrees here. After some time, phase equal to 90 degrees here. So calculate this distance upon the time. You will get speed of the waveform or speed of the wave. Any formula in this? Any doubt in this? Is this formula clear?
Yes. Yes.
So this is how the speed of the wave is calculated. For any wave, general equation was ax plus minus bt or x plus minus vt. V is equal to क्या आला होता? B by A. B means what? Coefficient of t. B is what? Coefficient of t. A is what? Coefficient of x. तसंच आहे की नाही बघा. This is B by A. This is also B by A. Coefficient of time upon coefficient of x. Coefficient of time upon coefficient of x. Coefficient of time upon coefficient of x. Times a coefficient b, x a coefficient a. Okay. The next point. The wave velocity v depends on the nature of the medium. The wave velocity v depends on the nature of the medium in which the wave propagates. It is independent of the source producing the wave. Yes, source will decide frequency of the wave. And medium will decide the speed of the wave. And the medium will decide the speed of the wave. Let us try to understand how this formula has been derived. Now we know speed of the simple harmonic wave is omega upon k. What was omega? 2 pi upon time period. What was k? Similar to 2 pi upon t, we can write 2 pi upon lambda. What will be this? Lambda upon t. Lambda is wavelength. 1 upon time is frequency. So do you know this formula? Speed is equal to frequency into wavelength. V is equal to f lambda. Okay, now here onwards, at least you have to remember this formula. You can remember speed is equal to coefficient of time upon coefficient of x, coefficient of t upon coefficient of x, omega upon k. And omega can be replaced as 2 pi upon t. K can be replaced as 2 pi upon lambda. Solve it, you will get speed is equal to frequency into wavelength. V is equal to f lambda. Sometimes some people use the letter n for the frequency. In that case, you will write V is equal to n lambda. In that case, you will write V is equal to n lambda. Sometimes for frequency, you use the letter n. Now, let's move on to the next slide. Okay, before that, let us check. Is there anything extra? Okay, here. Let us try to read this. If the waves of different wavelength travel with the same speed in the medium is said to be non-dispersive. Air is a non-dispersive medium for propagation of the sound. On the other hand, if in a medium the wave velocity of different wavelengths is different, for example, light in the water or glass, then the medium is said to be dispersive. Okay. First of all, tell me, who decides the frequency? Frequency is decided by the source. Who decides the speed of the wave? Speed of the wave is decided by the medium. Okay. Now, instead of saying wavelength, they should have said frequency. Instead of saying wavelength, they should have said frequencies. Okay. But we know speed, frequency, and wavelength are interrelated. Speed is equal to frequency into wavelength. Let's say we have wave having wavelength equal to lambda 1. we have wave having wavelength equal to lambda 2. We have wave having wavelength equal to lambda 3. For wave having wavelength equal to lambda 1, let's say medium is air, the speed is v. For second wave also speed is v. For third wave also speed is v. In that case, the medium is said to be non-dispersive. For all people, speed will remain same. For all the waves, speed will be same. Such a kind of medium which offers same speed for all the waves of all the different wavelengths or all the different frequencies is known as non-dispersive medium. Any doubt in this?
No.
There is a second type of medium also. There is a second type of medium also. Some other medium. Some other medium which offers speed equal to v1 if your wavelength is lambda 1. If your wavelength is lambda 2, I will offer speed equal to v2. If your wavelength is equal to lambda 3, speed will be v3. Such a medium which gives different values of speeds for different wavelengths of the wave, then the medium will be said to be dispersive. Any doubt in case of non-dispersive and dispersive medium? Non-dispersive medium is a medium which offers same speed for all the waves, of all the different wavelengths. And dispersive offers different speeds. Non-dispersive means it will not distinguish the wavelengths. For all the wavelengths, it will offer same speeds. So what is the wave velocity? Wave velocity is the speed at which the phase of the wave travels. Initially, the waveform was like this. After some time, same waveform will be available here. So the distance traveled by the wave divided by the time is called as speed of the wave. It is dx by dt. Now, there is a second concept, the particle velocity. The first concept is wave velocity. Second concept is particle velocity. You can give a fixed value of wave velocity, but you cannot give a fixed value of particle velocity. Can anyone tell me why particle velocity is not fixed? You can give a fixed value of wave velocity. This shape was initially here. After some time it will be here. You can calculate distance traveled upon time taken, or this distance traveled upon time taken. You will get speed of the wave. You can write the formula for speed of the wave. Distance traveled by the wave upon time taken by the wave. 1 upon time is frequency. Lambda is lambda. So speed equal to frequency into wavelength. You can get the speed of the wave. But for particle velocity, you will not have a fixed number. Can anyone give me the reason why particle velocity is not fixed?
पार्टिकलची सेम फेज आपल्याला परत मिळत नाही.
Particle
आपल्याला वेव्ह साठी जशी सेम फेज मिळू शकत होती पुढे, तशी पार्टिकल साठी नाही मिळत, एकाच पार्टिकल साठी.
Okay. Any other attempt? Wave velocity is the speed at which a given phase travels. So you can fix a phase and you can check that phase was initially here. Now the same phase is here. Now the same phase is here. You can fix a phase and calculate the distance traveled by the given phase upon the time. And that will give you the wave speed. And that will be a definite value. But in case of particle, actually particles are performing oscillations. So how can they have same value of speed at the mean? Speed will be maximum. Here, speed will be 0, maximum, 0, maximum, 0, maximum. Why we don't get the fixed value? Now answer. Now give me the answer. Why the particle has different values of speeds? Because it is
Oscillating.
oscillating. Okay. So what is the position of the particle? Now the particle is oscillating in y direction. So let us write y is equal to a sine omega t plus or minus kx plus alpha. Whenever not mentioned, you can take this initial phase alpha equal to 0. So you can write wave equation as a sine omega t, and whenever not mentioned, you can assume the wave is traveling in the rightward direction. If it is traveling in rightward direction, if it is traveling in positive x, use the minus sign. And whenever not mentioned, take this alpha equal to 0. So this is our wave equation. This is equation of oscillation of any particle at location x. If you take x equal to 0, it will become equation of oscillation of particle at origin. If you take this x equal to 0, it will become equation of oscillation of particle at origin. And if you keep any general value of x, it will be equation of oscillation of any general particle. Now, if you write dy by dt, what will be the answer? A omega sine derivative cos omega t minus kx. But what is dy by dt? Rate of change of position of particle is the velocity of the particle. So you can see the formula. Velocity of the particle is this. Now you can notice that this derivative should be partial derivative. Can anyone tell me why it is partial derivative? While calculating the particle velocity, we have to take partial derivative. What could be the reason? Why not dy by dt? Why dou y by dou t? This y not only changes with the time, this also changes with position. So here we have two variables. Out of that, we are considering one variable. So variation of y is considered right now only with one of the two variables, so partial derivative. Any doubt in this? How to calculate particle velocity? Any doubt in this?
No.
Okay, fine. Now, what will be the maximum particle velocity? When this cos function becomes equal to 1, or when the particle is at mean position, its velocity will be maximum. So what will be the maximum velocity? We know what is velocity of oscillating particle, plus minus omega into root of a square minus x square. आता x नाही म्हणायचं, काय म्हणायचं, y म्हणायचं. So at the mean position, y is equal to 0. So if at mean position y is equal to 0, what will be the maximum particle velocity? Plus minus a omega. And if you talk about speed, it will be a omega. Now you can also calculate acceleration of the particle. How will you calculate acceleration of the particle? What is the position of the particle? A sine omega t minus kx plus alpha. Let us take alpha equal to 0 and let us assume that wave is traveling in the rightward direction. So this is our equation of the traveling wave. Y is the position of the particle which is oscillating vertically, and our wave is traveling in the rightward direction. Now, what is the particle velocity? Dou y by dou t. If you take this dou y by dou t, you will get particle velocity. What is the answer? A omega sine derivative cos omega t minus kx. What is the particle acceleration? Take the derivative of particle velocity. Take the derivative of particle velocity, you will get minus a omega square cos derivative minus sine omega t minus kx. What is the maximum particle acceleration? AP max. What is maximum particle acceleration? Plus minus a omega square. Any doubt in this? Particles are oscillating, so rules of oscillations are applicable to the particle position, particle velocity, and particle acceleration. Wave velocity is different, and particle velocity is different. Speed at which wave travels is a fixed value. V is equal to f lambda, or V is equal to omega upon k. But the speed at which particle travels is not a fixed value. It is oscillating. It will have different values. Any doubt in this slide?
No, sir.
Okay, let us move on to the next slide. Let us try to calculate slope of the wave. This is interesting. Try to understand this. Let's say we have the wave at time equal to t. If you take a photograph, the string looks like this. The string looks like this, means actually this particle on the string. Let's say this is our string. Let's say this is our string. This particle is at the extreme, this particle is at mean, this particle is at negative extreme, this is at mean, this is at positive extreme. All right. At any general point, this position, vertical position is, let's say, y, horizontal position is, let us say, x. At any general position here, I want to calculate the slope of the wave. Okay, I know y is not only function of x. Y is not only function of x. It is function of both position and time. Right now, our wave is simple harmonic. So this function has to be simple harmonic function. So let us write simple harmonic function A sine omega t minus kx plus alpha. You can take that alpha equal to 0. Alpha means initial phase of the particle at origin. Initial phase of the particle at origin. That is alpha. Forget it. Let us take it as 0. Now, I want slope. So fix the time. I fix the time. Okay. So time wala part काय झाला? Fix झाला. Now we can check variation of y with the position x. So you can calculate dou y by dou x. This will give us slope. Dou y by dou x. Let us try to calculate dou y by dou x. You know how to take the partial derivative. Now only x will be treated as a variable and time will be treated as a constant value. So take a outside derivative. Sine derivative will be cos omega t minus kx. Now you have to multiply the answer by the derivative of the term to which you have taken x. This is the term to which you have taken as x. Now, what will be derivative of this with respect to x? You tell me. What is derivative of omega t minus kx with respect to x? Partial derivative.
Minus k.
It will be minus k. T is a constant. T is not variable now. So omega t derivative will be 0. And this minus kx derivative with respect to x is minus k. So you have to write here minus k. So this a into minus k, it is minus ak. Cos omega t minus kx. That is the slope of the wave. That is the formula for slope of the wave. Now the slope of the wave is actually negative ratio of particle velocity to the wave velocity. Slope of the wave at any given point is, okay, this is what? This is your wave velocity and this is what? Your particle velocity. The wave is traveling rightward and particle is oscillating up and down. If you take negative ratio of particle velocity and wave velocity, you will get the slope. Wave is traveling rightward, so wave velocity rightward, particle is oscillating up and down, so particle velocity upward. If you take negative ratio of particle velocity and wave velocity, you will get slope at that location. Let us try to prove this. Okay, what is the wave velocity? It is omega upon k, or you can also write it as omega is equal to 2 pi upon t, k is equal to 2 pi upon lambda. So it is distance traveled by wave upon time taken by wave. So 1 upon time period is frequency wavelength as it is. Okay. What is particle velocity? Particle velocity is the derivative of particle position. What is particle position? A sine omega t plus kx or plus minus kx plus alpha. Alpha is 0. Let us take derivative of this. What is derivative of this? A omega cos omega t minus kx. So this is the particle velocity. Now we have the particle velocity, we have the wave velocity, and we also have the slope of the wave. What is slope of the wave? Dou y by dou x. Slope of the wave is dou y by dou x. What was y? Y is a sine omega t minus kx. So what was dou y by dou x? Dou y by dou x is equal to minus ak sine derivative cos omega t minus kx. Now, what we will do? We will simply check how to bring this particle velocity in this slope. You can check this A is available. This cos is also available. So what is not available? Omega. So multiply by omega, divide by omega. Now this A omega and cos omega t minus kx. This A omega into cos omega t minus kx. This minus k as it is, and this omega also as it is. So minus ak by omega, not a, not a. A is already taken. This a omega into cos omega t separately, a omega into cos omega t minus kx, you have to write it separately, and this minus k by omega separately, minus k by omega separately. What is this? Particle velocity, instantaneous particle velocity. Maximum particle velocity is a omega. Instantaneous particle velocity is a omega cos of omega t minus kx. So this is your particle velocity. And what is omega upon k? Speed of the wave. So what will be k upon omega? 1 upon speed of the wave, and this minus sign as it is. So any doubt in this? How to relate slope, particle velocity, and wave velocity? Slope, particle velocity, and wave velocity. Slope of the wave is negative ratio of particle velocity and wave velocity. Slope of the wave is negative ratio of particle velocity and wave velocity. Up to this, any doubt?
No, sir.
हे सगळ्या गोष्टी थिअरॉटिकल आहेत, व्यवस्थित फक्त समजून घ्यायचे आहेत. त्यामुळे लेक्चर बोर होण्याची पॉसिबिलिटी आहेच, पण ते बोर जरी होत असेल तरी त्याला काही सोल्युशन नाही. शिकायचं असेल तर आपल्याला ते करावं लागेलच. Okay, try to solve this. देवदत्त, हे सगळं समजलंय का?
हो सर.
आदिती नलवडे, समजलंय का हे सगळं?
हो सर.
आदिती सांगलीची, समजलं का तुला हे सगळं?
हो.
हो सर.
अक्षता,
हो सर.
अक्षय, समजलंय का हे सगळं?
हो सर.
अनन्या,
हो सर.
असावरी,
हो सर.
अथर्व,
Yes, sir.
Gargi,
हो सर.
करिश्मा,
हो सर.
क्रिश,
हो सर.
लावण्य,
हो सर.
निहिका,
हो सर.
मुस्कान,
Yes, sir.
शाइज,
हो सर.
स्वरा,
हो सर.
तहिरा, okay. Now, has anyone solved this? The equation of the transverse wave in a stretched string is given as y is equal to, why it is a transverse wave? It is traveling in the x direction and particles are oscillating in y direction. So it is a transverse wave. Now lecture won't be boring. Solve with me. Y is given as a sine, they have taken 2 pi common, into x by 30 minus t upon 0.01, something like this. Okay, where y and x are in centimeter. Okay, x is in centimeter, y is in centimeter. Of course, this sine ratio, all trigonometric ratios are unitless. So this 2 and y should have same unit. So 2 must be in centimeter. This time is in second. Okay, find the amplitude. What is the amplitude of the wave? Step 1. Arrange equation into standard format. So write down y is equal to a sine omega t plus minus kx or kx plus minus omega t. So step 1 is complete coefficient. Don't take anything common. Here they have taken this 2 pi common. We want kx and omega t. Kx and omega t format. So step 1 is take this 2 pi inside. Take the 2 pi inside. What you will get? 2 pi upon 30 into x. So now you will have kx minus 2 pi upon, write down with me, 2 pi upon 0.01 into t. So compare this with y is equal to a sine kx minus omega t. Now you tell me what is amplitude of the wave with proper unit.
2
Centimeter.
2 centimeter. Second is frequency. How to find frequency? You can find frequency only by omega and you can find wavelength only by k. If you want frequency or time period, omega will help you. If you want wavelength, k will help you. How to find frequency? Which formula you will use to figure out frequency?
omega equals to 2 pi f.
Omega is equal to 2 pi f. So f is equal to omega by 2 pi. What is omega?
2 pi upon 0.01.
2 pi upon 0.01 into 1 by 2 pi. So answer is 100. Time is in second. So this must be in 1 upon second. 1 upon second means hertz. Wavelength. How will you figure out wavelength, or which formula you will use for wavelength?
K equals to 2 pi upon lambda.
K is equal to 2 pi upon lambda. So lambda is equal to K upon 2 pi. No. K is equal to 2 pi upon lambda. Any mistake? Yes, there is a mistake. K is equal to 2 pi by lambda. So lambda is equal to what?
2 pi upon K.
It is 2 pi upon K. So 2 pi upon K. K. What is K? Complete coefficient. Complete coefficient means don't take the 2 pi common. You have to multiply 2 pi inside. So K is 2 pi by 30. So it is 2 pi upon 30 will become into 30. So answer has to be 30. This X is in centimeter. This X is in centimeter. So K must be 1 by centimeter. K must be 1 by centimeter or radian by centimeter. This time is in second. So omega must be in 1 by second or radian per second. So this lambda must be in centimeter. And finally, wave velocity. Which formula you will use for wave velocity?
F into lambda.
Frequency into wavelength. V is equal to F lambda or coefficient of time. उलटा आहे डिस्टन्स अपॉन टाइम नाही. कोइफिशियंटच्या केसमध्ये उलट करायचं. कोइफिशियंट ऑफ टाइम अपॉन coefficient of x, omega upon k. You can use any of these. You can use frequency into wavelength, no problem. What was frequency? 100. What was wavelength? 30. So what is the answer? 3000. Frequency is in hertz, means 1 by second. Wavelength was in centimeter. So it is centimeter per second. So you can say 30 meter per second. Anyone has any doubt in the example number 5? No. I hope all of you have written this. Let me clear this. Now let me check who can solve this. बघूया कोण सॉल्व करते. बघूया पहिला कोणाचा होतोय. मेथड कोण सांगताय? सॉल्व नाही केलं तरी चालेल, पण सर मला मेथड कळाली आहे, मला मेथड सांगायची. यू कॅन डू दॅट. Calculate the velocity of sound in a gas. So we have to calculate velocity of sound wave in a given gas in which difference in the frequencies of the two waves. Okay. Now here we will assume the gas to be non-dispersive, means whatever may be the frequency, whatever may be the wavelength, speed will remain the same. Non-dispersive medium, it will not distinguish wavelengths and frequencies. For all of the waves, medium will offer same speeds. Non-dispersive medium in which difference in frequencies of the two waves, having wavelengths. They are talking about difference in frequencies, but they are giving wavelengths as 1 meter and 1.01 meter as 4 hertz. Difference in frequencies, f1 minus f2. I don't know whether f1 is more or f2 is more. So I will write mod f1 minus f2. as 4 hertz. So difference in frequencies has been given and speed of the wave is asked. Solution. We know speed is equal to frequency into wavelength. If you change the frequency, wavelength will change, but speed will remain same because medium is non-dispersive. Can I say that frequency is equal to speed upon wavelength implies frequency is actually inversely proportional to wavelength. More the wavelength, lesser will be the frequency. More the wavelength, lesser will be the frequency. Okay. So lambda 2 is more. Lambda 2 is more. Lambda 2 is more, 1.01. So F2 will be less. So actually don't write the mod here. You are sure now. You are sure that lambda 2 is more. Lambda 2 is more. So F2 will be less. More the wavelength, lesser will be the frequency. F2 is less. So no need to write the mod. So now you can write F1 minus F2. Not F2 minus F1. F1 minus F2 equal to 4. Now frequency is equal to what? Speed by wavelength. So F1 is V by lambda 1. F2 is V by lambda 2 is equal to 4. Lambda 1 is known. Lambda 2 is known. 4 is also known. What is the unknown? Velocity V. Now calculate the velocity V. Take V common. What will you have? 1 by lambda 1 minus 1 by lambda 2 is equal to 4. So V is equal to lambda 2 minus lambda 1 upon lambda 1 into lambda 2 into 4. Don't calculate reciprocals. Okay, it is difficult to calculate reciprocals. Always do the cross multiplication in these kind of questions. So V is equal to 4 lambda 1 lambda 2 whole divided by lambda 2 minus lambda 1. Speed should be a positive number. So 4 lambda 1 lambda 2 divided by lambda 2 minus lambda 1. So 4.01 upon 4.04 upon 0.01. So that is 404. Any doubt in this question?
No. No, sir.
Solve this. A progressive wave, traveling wave, non-progressive, stationary wave. Progressive wave means energy available in one region will be transferred to the next region. That is a progressive wave. Stationary wave, energy in this region will stay in this region, will not go anywhere. A progressive wave of frequency is equal to 500 hertz. Okay, is traveling with a velocity of wave velocity is given 360 meter per second. How far apart are the 2 points? 60 degree out of phase. Okay, so let's say this is the string on which the wave is traveling, and this is the instantaneous shape of the wave. Time equal to t. This is the photograph of the string at time equal to t. Now we have to figure out distance between the two particles having phase difference equal to 60 degree. Now this particle is at 90-degree phase, this particle is at 0-degree phase, so their phase difference is 90 degree. No, we don't want particles having phase difference equal to 90 degree. We want to figure out distance between the two particles having phase difference of 60 degree. What is the separation between the two particles having phase difference of 60 degree? We know phase difference is equal to phase difference is equal to total change in phase upon total distance. If you travel distance equal to lambda, phase changes by 360 or 2 pi, you can say, into your separation, into your distance. Change in phase is equal to change in phase or phase difference is equal to total phase difference upon total distance into your distance. So what is your distance? That is path difference. याला path difference म्हणायचं, याला phase difference म्हणायचं. So will be equal to what? Change in phase into lambda upon 2 pi. What is this change in phase? 60 degree. 60 degree, pi by 3. Wavelength we need to calculate upon 2 pi. Pi cancel. Answer is lambda by 3. Answer is lambda by 3. Now you tell me, how will you figure out lambda?
6.
Sorry, lambda by 6. Lambda by 6. बरोबर, lambda corresponds to 360. This path corresponds to 360. Then what path will correspond to 60? 1/6. Total path lambda corresponds to phase difference of phase change of 360. Then what path will correspond to phase change of 60? 1/6, 1/6. So orally also it is lambda by 6. Orally also it is lambda by 6. You tell me, how will you figure out lambda?
Velocity upon frequency.
Now you know v is equal to f lambda. Lambda is equal to v upon f. So what is the path difference or separation between the two particles having phase difference of 60 degree? Their separation will be lambda by 6. Lambda is v upon f upon 6. What is the speed? 360. What is the frequency? 500 upon 6. 360 upon 6, 60 upon 500. This is cancelled. So 6 by 5 is 1.2. 1.2 upon 10 is 0.12. Solve this. This symbol is nu, used for frequency. Let me check who can solve example 8. A transverse wave is described by transverse means
dx.
oscillations in y direction and propagation is in x direction. So direction of oscillation and direction of propagation are perpendicular to each other. Y is equal to what? A sine. You need complete coefficient. So don't take this 2 pi outside. Write 2 pi inside. So 2 pi nu t. Can you see 2 pi f omega? 2 pi f. Time coefficient is omega. Minus 2 pi by lambda into x. Can you see 2 pi by lambda? K. K is 2 pi by lambda. Omega is 2 pi f. So basically this portion is omega and this portion is k. Okay. The maximum velocity of the particle. Yes, particle is oscillating. So at the main position it will have maximum velocity. The maximum velocity of the particle will be 4 times the wave velocity, provided, okay, for this to happen, what should be the wavelength? For this to happen, what should be the wavelength? Solve this and tell me the answer.
B option.
Done?
Yes.
What about others? Anyone else? बाकीच्या येत नाही आहे. एवढं अवघड आहे. ज्यांचा आन्सर आले पटकन रिप्लाय द्या म्हणजे पुढे जाता येईल. वेळ जातो ना आपला.
झालं सर.
बरं. सो आन्सर्स आले की पटकन सांगत चला. म्हणजे काय करता येईल मला पटकन सॉल्व्ह करून पुढे जाता येईल. So let us solve this. What is maximum particle velocity? It is oscillating, so its maximum velocity will be a omega. That will be 4 times the 4 times the wave velocity. Wave velocity is coefficient of time upon coefficient of x. It is omega upon k. So I can cancel out this. So I need lambda. I have to keep this a as it is, where a is the amplitude here. Amplitude a. Our capital A is their small a. Our capital A is their small a. Keep it as it is. 4 times k. K means 2 pi by lambda. So this becomes 4 lambda by 2 pi. 2 and 4 cancel. So it is 2 lambda by pi. So what is lambda? Lambda is pi by 2 times the amplitude. Here amplitude they have given as small a. So that is pi a by 2. Option number B. Okay, solve this. Let me check who can solve this. Obviously, theory will be boring, but questions are interesting.
Option C.
What about others?
Third option.
Third option, sir.
Okay, let us check. The equation of wave traveling along positive x. Okay, we need positive x. So for positive x, can we have this minus sign here? Yes. Can we have this plus sign here? No. Can we have this minus sign here? Yes. Because this is not the answer, all of the above is cancelled. Why not option 1? What is the problem with option 1? What is the problem with option 1?
सेकंड एक्स सोबत फक्त 2 पाय येते, आपल्याला 2 पाय/लॅम्बडा पाहिजे.
Yes. Unit is not matching. This overall term has to be radian. Has to be in the units of radian or unitless, you can say. That is the problem. Correct answer. Units are not matching. Are the unit matching here? V by lambda is frequency, so it is 2 pi f, so it is omega, no problem. So yes, here unit is matching, and you already have this 2 pi by lambda. 2 pi by lambda means k. That is also available here. Lambda and x unit will cancel. 2 pi unit will be radian. So the correct answer is option C. So let us move ahead. Let's solve 2 more questions. Try to solve this. This is interesting. You have to justify your answer. Read carefully, think on it, give the answer. Anyone wants to justify the answer? Okay. What is the frequency of the wave? 100 hertz. Can I write 100 hertz as 100 oscillations per second? How many times the particle crosses the mean position? Okay. In 1 second. Frequency has been given and number of times the particle crosses the mean position in given time. Given time is 1 second is asked. You tell me, in one oscillation, how many times particle crosses the mean position? In one oscillation, how many times a particle crosses mean position? You can start oscillation anywhere you want, okay? You can start the oscillation anywhere you want. Let me start oscillation here. Let's say particle goes right. So here it crosses the mean position. then it comes left. So here also it crosses the mean position, and again it comes back, and again it comes back. This is the one oscillation. How many times a particle crosses the mean position in one oscillation?
2 times.
Two times. So write down like this. Frequency is equal to 100 oscillations per second, equal to 9, equivalent to. Don't write equal to, equivalent to 100 as it is. Oscillation or one oscillation can be replaced as 2 crossings. One oscillation can be replaced as 2 crossings upon second as it is. Upon second as it is. So equivalent to 200 crossings per second. Therefore, the answer is 200. One oscillation or one oscillation can be replaced as 2 crossing. Clear?
Yes.
Now, all of you reply me fast. Are the things taught in today's lecture, theory and the examples, clear to all of you?
Yes,
Yes,
sir.
sir. Yes.
Okay. Now I will send this PPT to you. Don't print it. Don't even read it. Just keep it with you. Okay. Fine. Now you can leave.